All right. Today we would continue our discussions with sedimentary rocks. We already talked about how sediments are converted uh, to sedimentary rocks through a process of rethification, which transform loose sediments into solid rocks, whereby sediments get buried beneath the soil surface, and then they start compacting together, and then cemented together. Today I want us to look at what we call clastic sedimentary rocks. If you can remember, when we started with these discussions, let me just quickly go there. We said clastic sedimentary rocks are those made from weathered rock fragments. So those are what we are going to deal with a little bit in more details today, so that we can understand them a little bit more. So now, clastic sedimentary rocks made from uh, uh, fragments can be classified based on their texture and the composition. Uh, so that is, for example, talking about their grain size. How big are the grains that makes up such rocks? Or composition, or they are basically shapes. Are they angular in terms of shape, or they are more of a spherical? So angularity and sphericity also plays an important role. How are the materials sorted? How are the materials sorted, the ones that have been cemented together? This is a typical example of a clastic sedimentary rock, whereby you have materials of different minerals being cemented together. So now those variables provide diversity of clastic rocks. Now, uh, the clastic grain size, if we are to classify this kind of rocks or sediments in terms of grain size, what is important is diameter. Remember, soil, for something to be considered as a soil particle, it needs to have a diameter of less than 2 millimeter. Anything larger than that is not classified as a soil particle. And the largest uh, texture in terms of soil particle is sand. Sand soil has the largest particles, while clay soil, silt soil, and the likes, they usually have smaller particles. So anything that is uh, beyond 2 millimeter in diameter uh, is therefore a rock. So you have, for example, boulders, you have combos, uh, and you have pebbles. So is gravels. I'm sure you have heard of gravels. For example, a gravel road. They don't call it a sand road because it's not made from sand. It's made from gravel, much more larger than sand. Uh, so now it means such sediments can be arranged in terms of their size, from those that are coarse to those that are medium and to those that are fine, right? Uh, so if you compare, for example, sand, silt, and clay, you would realize that uh, uh, clay would have much more smaller particles, right, than sand. So it's sealed. But then if you compare sand with gravel, sand will have smaller particles than gravel. So if you are using a sieve, there will be a sieve that sand particles, because they must be less than 2 millimeters in diameter, are able to go through, but gravel won't be able to go through. So now we have said those fragments are being transported. Uh, so it now means uh, closer to the source, closer to the source, that is where you would find larger clasts, while closer to where the deposition is taking place, which would be further away from the source, that is where you would find fine-grained materials. For example, if you go to Swakopmund, that sand at sea, it's pretty much fine compared to boulders that you are likely to find at the mountain base, for example. So it now means with increasing transport, the average grain size decreases, right? The average grain size decreases, and the reason is that, for example, the degree of transport, the amount or the distance that such materials, such class have traveled, would mean slowly but surely they are breaking down further into smaller pieces, right? They are breaking down further into smaller pieces. So, and they are much more easier to transport, because when the river, for example, when it's losing elevation, right, it's also losing uh, energy to transport larger loads, while smaller loads are still able to taken with by the river channel all the way up to uh, the final destination. So that is the reason why here we are saying uh, clastic sedimentary rocks changes with distance. Those that are angular in shape, this is an angular shape, would have been transported over a shorter distance, while those that are spherical in shape would have been transported over a longer distance, which basically mean that long distance has given enough time and enough effort for them to be rounded up. So, and fresh rocks, the craters, are usually angular and non-spherical because they have not traveled a long distance enough for them to be rounded up. Whereas those that have been transported over a long distance, in most cases, would be round in shape. So as a result, angular shape should mean that such materials or such class have traveled a negligible distance, whereas those that are spherical in shape have traveled a much more longer distance. If you would go to Swakopmund sometimes, just pick up a piece of rock, piece of small stone, look at what shape it would be compared to the shape of a small stone that you will pick up in window. So it means the one in window is likely to be angular in shape, whereas the one in Swakopmund is likely to be spherical in shape because it must have been transported over a longer distance. So you need to understand that.